both example 1 and example 2 are in standard form. And so we're going to start right now by identifying what is the vertex. So we're going to do the vertex for both problems. The vertex consists of an x-coordinate and a y-coordinate. And we're going to start by identifying what is the x-coordinate. So this is the formula. It will be on the board, but you do need to know how to use it. So let's identify the a, the b, and the c. For example 1, a is 2, b is 8, and c is 1. Whenever I replace a variable like a b or an a, I am going to put parentheses around it. Okay, so my b comes in here as 8, and my a comes in as 2. All right, what does that reduce down to? Negative 8 over 4, and that reduces to x equals negative 2. This is my axis of symmetry. This is the equation that splits the parabola in half. It is also the x-coordinate of the vertex. So if you're a visual learner like I am, I would go to negative 2, and I'm going to make a vertical line that cuts through the x-axis at negative 2. Now, how do we determine the y-coordinate of the vertex? Please grab your calculator, and the helpful hint is whenever you have to plug something in and we are going to replace a variable, we need to use parentheses. So I'm going to plug in this portion of the equation. Wherever I see an x, I'm going to replace it with negative 2. So 2 times, please practice with me, negative 2 squared, plus 8 times negative 2, plus 1. The output will be what the y-coordinate of the vertex is. So the y-coordinate of the vertex is negative 7. 1, 2, 3, 4, 5, 6, 7. I know this parabola is going to open up, and I can make a very simple 0, 0, 1, 1, 2, 4, 3, 9. Remember, this is the pattern that we always use when we are constructing a parabola. Now, we do have to change that. Whenever this number is anything other than positive 1, we always have to multiply the y's. So 0 times 2 is still 0, 1 times 2, 4 times 2, and 9 times 2. That helps me create or construct an accurate shaped parabola. Now, I know this is just a rough sketch, so it's a little sloppy, but this is always can be considered your 0, 0. And then this is directions. From this point, I'm going to go right 1 and up 2. Right 1 and up 2. I'm going to go back to the original vertex and go right 2, and I'm going to go up 8. Then I'm going to go right 3, and I'm going to go up 18. And I'm just approximating there. On the other side, I'll go 1 across, 2 across, 3 across, and now I've constructed a more accurate rough sketch. So the nice thing about standard form is we can easily identify the y-intercept. So the y-intercept for this particular problem is 0, 1, and we can see that's true. Let's look at the x-intercepts. That was the confusing part. You do not have to have the quadratic formula memorized, but it will be on the board and you have to know when to use it. Now, in this video, again, I'm going to show you how to do the least amount of work using a calculator to still achieve precise x-intercepts. So we do not want decimals unless they're terminating, unless it's like 2.5, 3.1, right? I don't want to round any. So what is the x for this problem? We can see the x is 8. I'm sorry, I said the x, I meant to say the b. The b for this problem is 8, the a is 2, and the c is 1. So I'm going to come down below, and I'm going to plug in the appropriate numbers. Just call me out if you see me make a simple mistake. Here we go. This is going to be 8, 8, 4, 2, 1. Looks good to me. Okay, so this becomes a negative 8. And I'm not going to put anything inside at this point, and 2 times 2 is 4. Now, this is referred to as the discriminant. I'm going to grab my calculator, and I'm going to plug this in to a graphing calculator. So I have 8 squared. Make sure to use those parentheses to hug any number that we plug in. And inside the square root, it's called the discriminant, we get an answer of 56. Let's look here. Is 56 on this list? It is not. Grab a calculator and quickly we're going to go upward. So here's where 56 would be, in between 49 and 64. I'm going to do 56 divided by 49. That doesn't work. 56 divided by 36. No. 56 divided by 25 doesn't work. 56 divided by 16 doesn't work. Divided by 9 doesn't work. Divided by 4, it does work. So I need to rewrite this at this level. I'm not going to turn this into a decimal. I want to say that again. And I'm going to rewrite this again as it was 14 times 4. The perfect square is going to go first. Coming up here so everybody can see it. So I have x equals negative 8 plus or minus. I know the square root of 4 is 2. And now the confusion often comes into, like, how do I reduce it further? Like, what numbers do I need to know in order for me to reduce? The numbers that I'm underlining are the numbers that we are going to evaluate. So this 4 has to be really kind. It has to be both shared with the negative 8 and the 2, not with the 14. The square root of 14 is stuck with the 2. So I'm rewriting this as negative 8 over 4 plus or minus 2 over 4 square roots of 14. And then I just will reduce each part. These are the two answers. Now, for many people, maybe even including myself right now, I'm like, okay, I did all the work, but like, how do I know if that's right? We're going to look at my sloppy graph to see if it makes sense. So I have negative 2 plus, and I'm going to change 1/2 into just 0.5, square roots of 14. Okay, negative 0.12. I can see that. Can I see that right here? That's really close to like a negative 1, negative 0.1. Okay, that looks good. Now the next time, instead of adding, I'm going to subtract. So now I'm going to do negative 2 subtract 0.5 square root of 14. And I have about negative 3.8. So there's 1, 2, 3, 4. That's right. So I agree with my two answers. I'm going to start by finding the exact x-intercepts. My A is negative 3, my B is negative 1, and the C is positive 2. So x equals negative B, well my B is negative 1, plus or minus B squared minus 4AC, all over 2 times A. Sometimes students only want to put this division sign on the back half. It does go underneath everything. 2 negatives make a positive. I'll come back and evaluate the discriminant in a second. And 2 times 2 is 4. Remember to use, yes, negative 3. Did I mess right here? Thank you for finding that, Katie. Up top, did I do it right?
Yeah.
Yep, okay, thank you. So here we go. We have negative 1 squared minus 4 times A times C. And the discriminant, when I evaluate it, is 25. Well, that's nice because the square root of 25 is simply 5. I do not want final answers left like this. We want to take it a step further. So how do I do that? One time I'm going to add. So 1 plus 5 is 6. I'll reduce it a little bit. The next time I'm going to subtract. 1 subtract 5 is negative 4. I'll reduce it a little bit. So one x-intercept occurs at negative 1. And another x-intercept, when I reduce 2 negatives, make a positive, and 4 over 6 reduces to 2/3. As a reminder, if you are somebody who struggles to know how to reduce fractions, I do want to give you the little shortcut. You can type it in, negative 4 divided by negative 6, find the math button, hit it once, and press enter twice, and it will reduce it for you. Okay? So I've done the hardest part. Let's go back now and let's figure out what is the vertex. X equals negative B over 2 times A. Okay, B is negative 1 and A is negative 3. So I have a positive 1 over a negative 6. So this is the equation of the axis of symmetry. For the vertex, it's also going to be the x coordinate. Now I'm going to use a calculator to identify the y-coordinate of the vertex. Negative 3, in parentheses, negative 1 6 squared. Make sure you use those parentheses. Negative 1/6 plus 2. Don't round. So what do you do when you get to this point and you're not supposed to round? Find the math button, hit it once, and press enter twice. And we're going to reduce this, we're going to change this decimal and equivalent fraction, which is 25 over 12.